All right, thank you, Peter. I want to thank everybody for being here. Like Peter said, I'm from ARDEC, so I just want to put things in perspective for everybody. So I work in the Joint Services Small Arms Program Office back at ARDEC. So part of our mission here is to look at small arms capabilities that are applicable for Joint Services. So we deal in any calibers from 50 caliber on down and 40 millimeter grenade munitions. So what I want to talk about today is the future integral target engagement system, but I want to focus on a lot of the underlying technologies and architecture that go along with that product. So I brought the technologies with me. They're on my right-hand side over here. We have a couple of demonstrators for the individual platform, a remote weapon system platform. But what you're going to be seeing is we're taking fire control information, that sight picture that you see, and we're coupling it to the actual mechanical movement of the weapon. So we're taking a lot of the focus that the shooter has to do and letting the computer and everything do its thing, so that all the shooter has to do or the soldier has to do is pull the trigger. For those of you who have hunted or fire weapons, the hardest part of firing a weapon is aiming the gun. So we're taking a lot of that out of the shooter's hand, and all he has to do is pull the trigger. So those are the type of technologies that we're still working on. From an innovative perspective, what you're really seeing now is embedded processing, actuator motors, sensors are getting smaller, smaller, and smaller, and faster, and we now have the ability to embed them in an individual type platform or a cruiser type of platform. So my analogy is that this is sort of like an M1 Abrams tank. You've seen pictures of that going down the road, and its barrels moving and it's firing. That's the same kind of technology we have here, that the shooter can move and fire, and he can fire at stationary targets and moving targets. So why are we doing this? So back in a couple years ago, we had a requirement. The small arms community says, I want to be able to engage targets faster. I want to increase my probability of hit. So we looked at a bunch of technologies. A lot of them filtered out, and the one technology we looked at was this active stabilization at the time. So the promise is that by using the computer in the loop and processing, we can increase probability of hit and engage targets quicker. If we engage targets quicker, we'll increase survivability for the soldier. So what is active stabilization? So there's a couple parts to active stabilization I want to talk about. You have the stabilized platform perspective, you have the auto-targeting perspective, tracking perspective, and the target classifier perspective. So all of those kind of technologies that have to come together and provide a holistic solution so we can put bullets on the target. All right. The first part is the stabilization perspective. I've talked about the motors where they're actively moving the barrel of the weapon up and down. They're doing what they have to do based upon all of our calculations. From the target classifier's perspective, and that's been one of the new kind of things that we're looking to do more work on, is because we haven't really brought software into a small arms target platform at this level as of today. So there's not a lot of target classifiers out there that we can deal with. So we've been building our own just to demonstrate how the technology works. So we're slowly integrating the target classifier information in there and coupling all together. Target tracking is it's a pretty mature type of technology. You've seen it out there where sensors identify a target and little boxes is drawn around it, and then as that target moves, the boxes move with it. But we're taking that a step further. So if you think about it like this, is that anybody here can be a target, or a vehicle can be a target. We're drawing that little box around there, but we want to be able to engage that target with precision. So precision to us means, from a small arms perspective, center of mass firing. So we want to be able to go to the contents of that box and focus where our fire would be. Normally it'd be center of fire, but I like to have folks think about it this way. If we're engaging the target and we want to hit center of mass. What if that target is wearing body armor? So now I have software on my system where I can say, hey, adjust your fires up or down and hit a more lethal area to engage the enemy. So that's the kind of capabilities that this type of system has. We've been testing it out from just a developmental perspective. And we've increased probability of hit over 50% on some of the testing we've done. So we're progressing with that. So I have two demonstrators over here. One's an individual demonstrator, and that was our early demonstrator to showcase that we can stabilize the barrel. But our focus today is on a remote weapon station platform over there on that pedestal. So the concept here is the same kind of thing. A lot of these remote weapon stations have a stabilization system built into them. We do some rudimentary stuff, but what we're building on top of that is that architecture so we can find a target, track a target, and engage the target. And the computer is helping us do it all. And all the soldier has to do is basically pull the trigger. It's separating himself from being behind the weapon so he can be defilade and protected, and then he can engage the target or targets, and then take care of what he has to take care of. So that's about it in a nutshell of what we've been working on. So my takeaways on this project here is that, and I tell folks at the office, is that now I have embedded software running on a small arms weapon platform. What can't I do? What can't I program it into find in this audience, or find in the field, or find whatever based upon the sensor systems I'm using, the cameras I'm using? I can take all that information, I can process it into my targeting computer, and then I can adjust my fires real time, not just for static targets. So if the target's moving, I can adjust real time and engage my targets. So for me, the bottom line is this: is that we're going to increase probability of hit. And to me, the most important part is I can, from a soldier's perspective, and that's what we're supporting, is they can engage targets quicker, with more precision and extended ranges. So from us, our technology is working, but it's also increasing the soldier's survivability because he's keeping out of arm's way, and he's engaging the enemy faster. So that's about all I have. If there's any questions, I'll be glad to take them. We have a couple working demonstrators over here if you want to see them in action. We have a couple sample targets set up over here. You can see how it actually works. Our remote weapon station is all set up to, minus the weapon, is set up to show how the target classifiers and the target ID operate, and how our initial concept is working for this type of application, because it is a new way of shooting. You're taking a lot of the fundamentals out of the shooter. Any folks here who have been in the military in the past know that you have all the fundamentals you have to go through to fire a weapon. A lot of this is taking those fundamentals out of your head and letting the computer do them. So please stop by, and we'll be glad to show you what we've been developing to date. And like I said, any questions, stop by, or I think we have time. All right, thank you.